Hey, how you getting on? Welcome back to the series where the baldest man on guitar YouTube is either on his way to getting a new tube amplifier, several electric shocks, or a very expensive fire, or a combination thereof. This is a video series where I attempt to build a 50W Plexi kit from and with my friends from Tube Amp Doctor. This is part 2 of the series. If you haven't seen part 1, you might want to check that out first. But if you couldn't be bothered, here's a quick summary. In the first part of this series, we mounted the hardware parts of this amplifier. We put in the transformers, the pots, the tube sockets, and all of that good stuff to get an impression of how much space we will have to see if the kit is complete and just to organize things basically. And we took a brief look in the theory section at the schematic with some focus on the power supply. What I want to do today in the build portion of the video is wire up the components we have in the chassis already, so kind of trim these transformer taps and everything, just organize this a bit to prepare it for the turret board, which will be the next part of the series. And in the theory part, I want to take a look at the filaments, so the tube heaters and the filter capacitors. All right, let's go. So I'm kind of nervous about this part as I'm not really exactly sure where to start. There will be a few areas in the chassis that will end up being a little congested. One area is this around the transformer and the power switches here. We don't have much space here. And obviously there's a lot of wiring going on here that I'd like to clean up. So I'll likely start there. The other area that'll be kind of tight is around the speaker output jacks, the impedance selector switch, and the power tube sockets. So there'll be wires from the transformers coming out through here. The area around the potentiometers is going to be fairly busy as well. One thing that is making me slightly nervous are the filaments, the tube heating. So we'll want to twist these wires and wire up all these tube sockets here. So I've got decent tools lying around here somewhere. I have my Hackle soldering iron. I need to wet this sponge next. Pliers, if you're like me, you're going to need a desoldering pump and maybe some wick as well. Multimeter, here, most important, wire stripper. That probably clipped the preamp. Yeah, right on. Let's fire up the soldering iron. And I have this little extractor fan here because everything that's fun is unhealthy for you. And I don't want to get high off solder fumes. Well, I actually do, but I shouldn't get high off solder fumes while doing this job.
Hey, it's VoiceOver Me here. I was going to narrate this as I build, like I did for the first part. At the same time, I greatly underestimated how long I'd take for this part of the build. Overall, I ended up with about 7 hours of raw footage. My videos tend to be long, but that's too long. So I decided to speed it up, edit it, and narrate it this way. As you can see, I'm starting with the power switch. I was concerned about certain areas of the build that would end up being a little congested, meaning there'd be lots of wires and connections there. So one of those areas would be the starting point. I decided to start kind of left to right, at least from my perspective, starting with the mains transformer and then moving through the chassis that way and finishing up at the front of the chassis with the pots and the jacks. So as you can see, I'm wiring up the main switch to the primary of the power transformer. I'm starting on the primary side. And now I'm soldering up the soldered terminal at the side there where the wires from the mains transformer that are not used are connected to, as well as the 120 volt line for the pilot light. Initially, I was kind of held back by a few things, one being my soldering iron, which is a Hackle FX888D you're able to see right now. Now that's a fantastic soldering iron, it's great. Unfortunately, I bought it years ago with pedals in mind and only had a very small soldering tip for that, which means heat transfer didn't work quite so well. You're able to see that I need to hold the iron on the terminals for a fairly long time in order to solder them, and that caused the solder joints to look kind of crappy, and I wasn't happy with that, so I changed to a different iron later in the video. Right now I'm connecting the standby switch, I'm connecting it to the secondary wires, the high tension lines. Here I'm tinning up the wires, bending the terminals so that I get at them, mounting the standby switch. And you can see I have a yellow wire coming off there that is connected to the turret board later. That's another high tension connection. I wanted to solder up the connections on the switch before putting them in, and I prepared for that there. Now I'm trying to wire up the rectifiers, as you can see. Those are 2 diodes mounted to another terminal strip that is connected to the chassis. And I'm kind of bending the diodes in place. And right now I remember that the rectifier diodes are soldered to a terminal of the filter capacitors. So before putting that in, I need to mount the filter capacitors, which I hadn't done before. Here's me checking that they all have the same value, unpacking them, and then I need to pop them into the clamps. First one goes in fairly easy, loosen the clamp, fail at that, try again, and pop it in. Last one, and now they need to be clamped down. Look at that monkey go. Riveting television, isn't it? And here's the second thing that held me up initially. The wires included by Tube Amp Doctor are pushback wires. I'd never heard of these before, and I was wondering why they were called that, all while trying to strip the insulation. I later realized that all you have to do is push the wires back. So just cut the wires to length, push them back, kind of like peeling foil off a sausage, if you know what I mean. So with the wires prepared, I put the terminal strip in, try to bolt it down like the monkey I am. So with the rectifiers in place, they need to be soldered to their connections on the filter capacitors as well as the standby switch. Kind of gauging how long the connection has to be by routing it preliminarily, then cutting it to length and soldering them onto the switch. The Hakko soldering tape is kind of just good enough to solder those connections on the switches, but the solder connections on the terminal strip on the side there, they kind of bother me. And later on in the build, I realized that I screwed up and made them too short. I was annoyed with how untidy that looks with the wires being so short and going there. So I spliced them back together with heat shrink hose and reroute them. You'll just see that subtly change because I did that off camera. I was too ashamed of my horrible mistake. Cutting off the excess lengths there of the components. Here's me clamping down the fuse holders. For some reason, I'm going to have to loosen them again later. And now I'm preparing to wire up the IEC connector and the mains fuse to the power switch. So those are the blue and brown wires that are supposed to be twisted along the side of the chassis. I'm just hooking them in there and soldering them to the switch. Not cutting them to length yet because I don't know how long they need to be, as they need to be twisted. Great success. I'll start twisting them in order to wire them along the side of the chassis. Thing is, at this point I'm about to realize that there are components underneath the fuse holders and the IEC switch, the filter capacitors, that will need to be wired up first. So I just leave the wires hanging out there, kind of prepared for later, and start wiring up the filter capacitors. Again, start messing with the fuse holder. I'll have to loosen that again later. And here's where I discover one of the great advantages of the pushback wires, because they're wires, they're not actually stranded cables, they're firm wires, they stay in place. You can bend them into nice shapes and they stay that way, which looks very neat. I was actually pretty stoked on that. I thought that looked pretty cool. But as I said, the schematic said non-specified wires with that yellow wire. And I'm also using that to wire up the ground connections of the filter capacitors. Later on, I realized that that should probably be the black wire included in the kit. And photos on the Tube Amp Doctor website also show that. So that's something I will be rewiring as well, but also off camera. Some of those wires will just suddenly look black to you guys. So what I'm doing next is I'm connecting the earth connection, the grounding, to the IEC connector. And I think in the schematic it says to use leftover wires from the mains transformer, but there's no green and yellow wire in that or on that mains transformer. So I just stripped a power cable I had to have it up to code using the green and yellow wire. Here's me starting on the ground connections. There are solder terminals that connect it to the ground. One is for the IEC connector, and the second one is for the ground node at the back of the chassis there. 2 ground connections from the power transformer go there, as well as the filter capacitor, I believe. So the two orange wires there are the tube heatings, the filaments. They need to be twisted and routed along the back of the chassis to the respective tube sockets. And here's me yapping about something, still confident that I'll be able to narrate this as I build. As you know now, that's not going to be working out. I'm complaining, I think, about my soldering iron, that the tip isn't large enough and the heat transfer isn't working well enough. I will be reflowing those joints on the solder terminal later, and then later actually rewiring the whole thing. Here's me complaining about the pushback wire, or not complaining about that. Here's where I know what that is, and I'm demonstrating how to use it. I even made a reel about that, I felt so dumb. So, quick double check on the schematic, and I'm starting to route the wires from the mains transformer, those two orange ones, F and F1, which are the tube heatings, the filaments. I'm already putting them in place to wire them up to the first octal socket. But before doing that, I'm making sure that the ground connections are in place. That's the black wire there. I'm trying to bend that in shape to connect the ground to the octal tubes, pin 1 and 8 on both of them. And again, that's the cool thing about the pushback wire. You're able to bend it into shape you need it to, and you just solder it in. And it looks really, really cool. Actually, the whole thing ended up looking a little better than I was hoping for. Usually, I'm pretty catastrophic at that. My pedal builds, you know, wires were either too long or too short. This one actually worked out quite well. Here's me trying to bend the pin or the connection of the wire in place in order to solder it to the second octal tube base. Here I'm trying to take a little bit of wire to bridge the pins 1 and 8 and solder that in place. The cool thing about the pins on those octal tubes is they have 2 holes, so 1 hole above, 1 hole below, which allows you to connect 2 or more wires to that pin more easily. With a quick check on the schematic. De-twist a bit because I had too much. And here's me marking one of the connections F1 with tape because I wanted to wire those in phase. I wanted F1 to be the same pin on every tube socket and F to be the same pin on every tube socket as well, just to have the heater wires in phase. There's me connecting the orange wires. And it's starting to look a little more tidy. Sniffing a bit of solder fumes. Now, for the filaments or the tube heaters, Tube Amp Doctor included that green wire there, which is a little thicker than the yellow wire, but also a little stiffer. So I'm cutting the green wire in half because I have 2 connections, F and F1, that need to be made, and the green wire isn't used for anything else in the build. So I soldered that to pins 2 and 7, I believe. And then I will attempt to twist that through the back of the chassis to the next socket. You saw there I marked one with tape again. Now this twisting of the wires turned out to be a little more challenging than I expected it because the wire was fairly stiff, which is good. It'll make it stay in place, but I had to make a few attempts to have it actually satisfactorily twisted around itself. Here's me trying to bend the bare connection of the wire into place. Quick inhalation of some solder fumes, bending it into shape. I'll be honest with you guys, this process took an awful lot of time. It was a little more challenging than I expected. Here's a brief moment of despair with me questioning my life choices, because now that I've got the filaments wired up to the octal bases, which are for our power tubes, I need to continue routing that connection onto the novel sockets for the preamp tubes, which are 12 AX7s. Now, as you know, each 12 AX7 has 2 triode gain stages, which means more heater connections. Pin 9 is for F1, but F needs to be wired to pins 5 and 4 on each of the tube sockets. Now, the 12AX7 tube sockets, the Novel tube sockets, have smaller pins. It's a little finer, so I'm going to be at this for quite some time, bending pins and connection, using wrenches to hold the wires in place while soldering. It was a bit of a pain in the ass, I'm not gonna lie. Man, look at the veins in that head. I really should have gotten that chassis stand from Tube Amp Doctor for this. Now here's where I struggled. You see that? That pin just won't stay where it's supposed to be. Ah, popped out. Finally got it done, eh? Unfortunately, there's another one there on the side of the chassis where you can't see it because the chassis is covering it. No, I actually didn't make it. Screwed it up. Here's me trying for the third time. Here's me trying to wire that connection on so I can route it to the last preamp tube. See, I even had to use the desoldering pump here, which, considering that it's made of plastic and seems rather flimsy, works surprisingly well. Now, the nightmare with the filaments is about to end. I've almost got it done. Trying to tidy it up a bit, bend the wires where they need to be. Make sure that nothing's making contact that shouldn't make contact. Finishing touches, poking around a bit. Yeah, I just... Now what I have here is the impedance selector switch, and I've got it connected to my multimeter that I've set to continuity. What I want to do is check which setting makes contact between which pins, because the last thing I wanted to do was wire up the 16 ohm wire from the output transformer to the 4 ohm connection or the 4 ohm setting on the switch. That wouldn't have been nice. Now I'm putting the speaker jacks back in, and the contacts of the speaker jacks, because they're wired in parallel, kind of get connected with this stripped 18AWG wire. I've got loads of that green wire left, so I strip that. I solder one contact each just to keep the wire in place. Connect the others, but I leave the outer ones free because they need to get connected to the impedance selector switch and the chassis ground. And I only want to make that solder connection once I have all the wires in place. So I'm remounting the impedance selector switch. Now I'm routing the wires from the output transformer. And that was a bit of back and forth because, as I mentioned at the very start, that is a very congested area and I was experimenting a bit. First, I had those wires routed through underneath the ground connection, but then I thought gravity won't do me any favors. I should probably put that up there. I'm cutting them to length, kind of preparing the ends. Those are the stranded wires. Connected the orange wire to the ground connection of the speaker jacks. And now I'm ready to solder the wires to the impedance selector switch. Cutting off some extra length to wire everything to the speaker jacks. Bit of bending and tidying. As you can see, I've got headphones in. I'm probably listening to the Big Les show. What I'm doing now is wiring up the other side of the output transformer. Those are the plate connections. White goes to one of the octal tubes, pins 3, and red to the other pin 3 on the other octal tube socket. Cutting to length, soldering to the pins. And now I need to put on the screen resistors. And that was a little challenging as well because they're quite big. They need to be rated quite highly. And just to keep it in place, I used the engineer's best friend, tape, which worked fairly well on the first one. Quick check of the schematic. Now I'm preparing to wire up the choke, which is connected to the B+ fuse as well as one of the filter capacitors. The yellow wire I'm fidgeting around is for the screen resistor connection. They're connected between the two octal tube sockets and are then later routed to the turret board. So I'm preparing that connection already. That's why the second screen resistor isn't in yet. So as you can see, I'm snipping the leg of the second screen resistor and trying to pre-bend the legs into the correct position. Trying my best with tape again, failing miserably. Readjusting. See, this is a difficult job. I've rolled up my sleeves. Failed at soldering, so I had to soften that up again so I could even get the leg into the tube socket pin. Failing again, keeps falling over. Another attempt with tape, and I think I might have gotten it that time. Yep. Here's me making the second connection for the choke. As well as the brown wire from the output transformer. Final tidying. And here I'm checking that all the ground connections are still intact. Now with all that done, I'm finally ready to wire up the IEC connector. That wrench in there is just to keep the wire in place so I can solder it. It's ghetto engineering. It's connecting the mains fuse to the IC connector. I'm finally done. Now I'm moving over to the front panel. There's one bare wire connecting all the potentiometers to each other according to the schematic that's supposed to be stripped AWG18 wire. Again, I had lots of green wire left for the filaments, so I stripped a piece of that. Strictly speaking, that's not really necessary because each pot is grounded through its chassis connection. So yeah, grounding schemes are quite complex. Merlin has a great article about that, and Psionic Audio has 2 great videos on that. I might link to those in the description. Actually turn the chassis around here because that was an awkward position to solder in, but I wanted to show you guys. Now double check the schematic. The black wire there was a ground wire that will be used for the filter cap that is kind of in the middle of the chassis there. That will be covered by the turret board when it comes in. I wanted to make sure the ground connection was already made. So what I'm doing here is connecting the big capacitor to the presence potentiometer. As well as the 4.7K resistor on the other side of it. There's another cap on volume 1, but I'm not soldering that in there now. I've just bent the pins in there to keep it in place. I'm not soldering it yet because wires from the turret board connect there as well, and I don't want to resolder the connection. I just want to solder everything in place in one go. So what I'm doing next is connecting up the input jacks. And those are switching jacks, meaning they open terminals when a wire is connected there. And somehow, for some reason, those contacts on jacks, they always throw me. I had big problems with pedals there. I just, for some reason, have trouble understanding how the switching works. But it's brilliantly simple, really. And I'm going to talk about that in the theory section in a couple of minutes. So I've taken out 2 of the jacks so that I have enough space to solder the pair for, I think that is inputs 1. And you'll see me taking them out and putting them back in repeatedly throughout this process just so I can get better access to them. I put the ground wires in them, solder them in place, which kind of fixes their position. And then I take them back out to solder the finer components on. Now I've got the first pair almost ready. I've connected the ground to the potentiometers, as well as prepared the cable that goes to one of the grids. Now, clever as I was, I moved that extractor because it wasn't working very well where it was, but it kind of covers the camera. That wasn't very smart. Same process with the second pair of inputs, but I'm using my little helper to keep it in place in order to be able to show you what I'm doing. That's the black wire, that'll be the ground connection. Failing miserably. And the yellow wire will be the connection to the grid. I'm so preoccupied that I put those red or orange washers back in, which are just really spacers used for adjustment. I'm going to need to take those out again. Here's me double checking the ground connections, making sure that things that are supposed to be connected to ground are connected to ground, and things that are not supposed to be connected to ground are in fact also not connected to ground. Quick check on the schematic, which pins need to be connected to which input. hooking them in place, leaving some slack in case I screw up. Make it one more connection. And then, after almost 7 hours, I'm finally done.
Righto, finally done with prepping the chassis for the turret board. That's cool. That took a lot longer than I thought it would. Anyway, I'm going to move over to my desk and we're going to do the theory section where we're going to talk about the filter capacitors as well as the diode rectification. I think I already want to talk about the input jacks and how they're switched for different input impedances and stuff like that. And then next time we're going to, put together the turret board. And in part 4, we're going to put the turret board in and hook everything up. All right.
Right, let's look at the schematic again, but before we start, I have to mention again, I'm a mechanical engineer, I'm an automotive engineer by trade. I'm not an expert in this. I know how tube amps work in principle because I've been dealing with them for years, but I've never really built them. And my stupid brain kind of works this way. I grasp concepts or general concepts fairly quickly, but to really understand something, I need to be actually doing it. I'm a very much learning by doing kind of guy, which is one of the reasons why I wanted to build a tube kit in the first place, to actually fully understand it. So I can't guarantee that 100% of the information I'm going to convey here is 100% accurate. Please take note of how I phrase things. If I say I believe, then I don't know for sure. But I know my audience also consists of people who know more about tube amp theory than I do, and if I say something incorrectly, please drop a comment down below. And I'll pin a correction as a comment if that occurs. But if you want to learn about tube amp theory, how they work in great detail, there's fantastic sources out there. One of them is valvewizard.co.uk by Merlin, whose last name I not dare try to pronounce in fear of mispronouncing it, but he's got fantastic books and a fantastic website. Aiken Amps is another fantastic website with great information. He's got loads of white papers, and Rob Robinette, of course. And if you're interested in this kind of content on YouTube, there are great channels that poke around inside amps and fix them and actually know what they're doing, like Head First Amplification, fantastic YouTube channel, and of course Psionic Audio. Anyway, we're looking at the schematic of the tube amp kit I'm building right now, which is the Plexi 50W lead model from Tube Amp Doctor. In the last episode, we went over the power supply and did a brief scan, a brief overlook over the schematic overall, how it works basically fundamentally. Today I want to talk about the rectification, the filter capacitors, and I want to start talking about the signal lines starting at the inputs. After the power gets transformed up from our mains voltage, which in my case is 230 volts, up to voltages that we need for the internals of the tube amp to work, that AC current needs to be rectified to DC current. And we do that by using a rectifier, which in this case is a circuit consisting of silicone diodes. Now, when I first saw this, I was very confused. I was expecting 4 diodes, a full bridge rectifier, which kind of looks like this. This is the schematic for the PV Valve King I made a video on the other week, and that has a full bridge rectifier as I know it. A little circuit consisting of 4 diodes that are arranged this way. There's a load on one side and the source AC connects to these other nodes. The way this is set up, there's always 2 diodes passing signal independent, whatever the phase of the mains current is, and it's put together on the load side here to DC current. So I was kind of confused when I only saw 2. I wondered how was that going to work? And the trick is the center tap, which provides a ground reference. So for half the cycle, one of the diodes is always conducting, and it puts together a DC-like signal. Now, this signal won't be stable DC voltage. It'll have little ripples on top. It won't be very steady. And that is one function of the filter capacitors here. You can think of these capacitors basically as fast charging and fast discharging batteries. They store charge and they smooth out the DC current that way. And you'll see that they are spread out throughout the schematic. In the actual amp, they're closer together. We have 2 of them here and 1 of them over here. But you'll notice that in the schematic, there's 6 symbols. That's because there are 2 capacitors in each one of those buckets there. Now, these capacitors don't just smooth out the DC current, they also provide energy for the stages when there's large transients, also strong signals going through the amp, so the amp doesn't kind of sag down too much. So if you put more capacitors or more capacitance into the filtering of an amplifier, the amp will be a little stiffer. If you reduce the capacitance or the capacity, you will have more sag. So the capacitors greatly influence the feel of the amplifier. And you'll see here that different capacitors supply different parts of the amplifier with charge or with energy for, large transients, as I just said. They are separated by dropping resistors. These are large 1 watt 10K resistors here. What they do is they drop down the voltage. At the beginning, you'll have something like 450, 460 volts to supply the plates of the power tubes. That's where we need the most high voltage. Then the voltage is dropped down a bit, maybe around 400-ish. I'm not too sure about that, of the exact value, but less than the plates for the phase inverter. And the voltage gets dropped down all the way to the first stage, which typically has the lowest voltage on the plates in the circuit. Now, these resistors don't just drop down the voltages. Together with the capacitance of the filter capacitors, they kind of form filters as well. So they isolate the stages from each other a bit so we don't have noise and interference. This up here is our choke. And for all intents and purposes, that's a coil, which creates an electromagnetic field in which it stores charge, electric energy. So it also contributes to the ripple filtering of the DC voltage. But in modern amps, we don't have chokes very often. Often there's a resistor in that place, which causes more of a voltage drop and affects the feel of the amp. I'm not 100% sure in what way the choke affects the feel. I know that adding a choke as a popular mod for Marshall JVMs, for example, I believe it might make the amp a little tighter because the voltage drop isn't so large. Not 100% sure. In these classic Marshall circuits, we often have a choke in this position. Yeah, righty. And I think that concludes everything I have to say about the supply side of the tube amp. I want to move on to the signals next. And I found this particularly interesting. We're looking at the inputs here, and the Marshall Plexi famously has 4 inputs. 2 inputs are for the normal preamp and 1 for the bright preamp. Volume 1 is the brighter one here. Volume 2, those are the pods, or channel 2 is the darker one. That has to do with different filtering for one thing coming out of the stage, as well as different cathode resistors and cathode bypass caps as well. Each of these stages or channels have 2 inputs, 1 low gain input and 1 high gain input. And the low gain input is about 6 decibels attenuated compared to the high gain input. And the way that works is simple but brilliant. And it took me quite a while to understand, I have to admit. So this up here is the low gain input, and the one below that in the schematic is the high gain input. So when we pop the guitar cable into the low gain input, these contacts here open, so there's no connection there. The signal flows along here through this 68K resistor to this node, which is connected to the grid where the signal is amplified in the stage, but it's also connected to this other grid stopper resistor, the other 68K. So there's a voltage divider here, goes through here, through these contacts, and then to ground. So the input impedance of that input is about 68K. That is the resistance to ground. When we stick the cable into this input, these contacts open, so there's no connection here. The signal flows to this node. There's a 1 mega ohm resistance to ground, so the input impedance is 1 mega ohm. The signal can go through this 68K grid stopper up here and through this 68K here. So the grid stop resistor effectively is half that value, so 34K. That means we have higher input impedance. There's more resistance to grounds, so more signal will go to this stage, to the grid, but also the resistance in front of the grid is also effectively lower. So we'll have a stronger signal going to there. I think that's brilliant. And if we look at the layout, the way it's done there, so here are the input jacks. Now, if we stick the cable in here, this is our high gain input. We have ground connections on the ring side of both of them. There's a bar going through here. The signal comes in here. There's a 1 mega ohm resistance in the way to the ground connection. This pin
where the cable is inserted isn't connected to the actual cable going in anymore. That contact opens, so there's no direct ground connection there. There's a 1 mega ohm in the way. The signal can flow through this 68K resistor, but also up here to here, because that contact is closed, there's no cable in there. The signal can also go through this 68K resistor, and they join up back here to go to the grid. If we plug the cable into the low gain input, we still have the ground connection here. This contact isn't connected to the cable anymore because there's a cable in there. The contact opens. The only connection that is left is this 68K, to which the signal flows to the node where the grid is connected. But there's this other 68K resistor, which is also connected to that node, which links to this pin. Now the signal doesn't have to go through the 1 mega ohm resistor because there's no cable in here. That means these two contacts are connected, and therefore the input impedance, meaning the impedance of the resistance to ground, is 68K here because that is connected to ground. It took me an awful lot of time to understand that, and also just explaining that, even though I've gone through it like half a dozen times, it keeps scrambling my brain. I always have to think, wait, what's happening here? It's really simple, but it throws me every single time. I can't explain it. Yeah, but anyway, that's why. Yeah, that took me a while. Anyway, so I think that concludes part 2. In the next part, I will be attempting to populate the turret board. I notice I swallow a syllable there quite often, and it sounds like I'm saying turret board. I mean turret board. I'm going to try populating that and getting it ready to be put in part 4. And in the next theory section, we'll be talking about the preamp. So how a triode gain stage works, what all these components are for, what is a grid stop resistor, what is a cathode bypass cap, what is a cathode resistor, what is a plate resistor, what is all this stuff, what is this EQ, how does it work, and so forth. So thank you very much for watching, and I hope to see you in the next video. Bye bye.